How does sound wave propagates in a medium? How does sound wave propagates in a medium? It propagates. No. Yes, it propagates in the form of wave. Right? And then we said, which kind of wave is sound wave? Longitudinal, right? So in the form of wave. So wave is basically what? What is wave? What is wave? We discussed that also. So wave is basically a disturbance, right? So wave is a mode of transfer of energy. So basically, there are two types of waves that we need to know. We have longitudinal and what is the other one? Transverse. Sound is which type of wave? Longitudinal. Only longitudinal. Sound is longitudinal. Sound wave. The example is sound wave. I'll explain what is the difference. I think I have not told you what is the difference. Transverse wave is like waves on free water surface. Waves on free water surface. Right? Then this is 1 second in strings of musical instruments. Everybody can see what is written on the board. Yeah. So in strings of musical instrument, right? What else? Light wave. Now these are all the waves which are traveling in medium. What is the medium? The string itself. Here, what is the medium? Water. There is a transverse wave which is light. Light is also transverse wave. But there is a difference with respect to the other transverse waves, which can travel without a medium. Excuse me. Without a medium. Okay. So light is also a transverse wave, but there is no medium needed. Can it travel through the medium? Yes, because light can pass through glass. Okay. So what is the difference? Therefore, and it is also called as, so all these waves which need medium to travel. Okay. Sound wave also needs medium to travel. Which medium in which sound travels? What are the medium? Air. So which is gas basically. What is air? Gas. Can it travel in solid? Yes. It can also travel in liquid. So sound can travel in all kinds of mediums. Right? And here are two examples of transverse waves which are also requiring medium. So such waves are called mechanical waves. This is medium 0. Okay. Okay. It's medium or propagate. ठीक है तो दोनों लॉन्जिट्यूडनल और ट्रांसवर्स दोनों मैकेनिकल वेव है जहां पे मीडियम की जरूरत है ठीक है whereas light is a transverse wave which can travel with or without a medium. It can travel in vacuum also. Okay. Now what is the difference between the two waves? So in case of sound wave, if we take the example of a tuning fork, right? Now this will it will go sometimes in front and then it will come back. This is the mean position. This is the rest position of the tuning fork. It will vibrate like this. Okay. So when it goes in front, that time what it will do? It will compress. the air particle, right? And when it comes back, that time it will relax, right? Compression and relaxation will lead to compression and rarefaction. So you'll have all these kind of things. I showed you in form of waves, right? Like that. So in this kind of situation, why this compression took place? Because these air particles, right, became close to each other, right? Then what is happening to the air particle? Let us say I take only one air particle over here, right? So when this tuning fork went ahead, it was initially at this position, then it went till here, okay? And when the tuning fork came back, this also came back here, and again it went back till here. Okay, so the air particle is only the air particle is not leaving its position. Okay, meaning if somebody is listening to this sound wave from here, right, this air particle is not going into the ear of that person. What it is doing is it is disturbed from its position, then it disturbs the next particle, it disturbs the next particle. So from particle to particle, the energy is transferred. Okay, like if I have to give this book to her, I can give it to you, and then you can give to her, and she can give to her. I did not go there, but the book reaches her. So it is passed from particle to particle. This is how. So this, what is the? So sound has reached here, right? So what is the direction of sound wave? This direction. And what is the direction of motion of the particle? Parallel. So when the particle of the medium oscillates parallel to the direction of wave propagation, right? Then we call it as longitudinal wave. Got it? Particle vibrates. So particle vibrates parallel to the direction of wave propagation. Okay, in which type of wave? In longitudinal type of wave. Now let us see what is the propagation in case of transverse wave. So let's say you have a water surface. Now some stone is dropped here. So the stone comes down. And then what about the water which was earlier here? That water will go down, will come up. Because of that, it will cause disturbance to neighboring water molecules. Then what do you see? You see something like this. The ripple which keeps on traveling on the both sides. Right? So how is water molecule oscillating up and down? How is the wave traveling? This way. The oscillation of water molecule is like this. The wave is traveling horizontally. The particles of the medium are oscillating vertically or perpendicular. So in this case, particles of the medium, right, oscillate or vibrate perpendicular to the direction of wave propagation. Understood? This is the major difference. Here the particle of the medium oscillate up and down. The wave is traveling horizontally. All right, is it understood? So just take quick note of this concept. Now if you read your notes, you will understand also. Right? So if you want to write, you can write. So these are the where the particles come close, they are called compression. Then you have rarefaction. Then you have compression, rarefaction. In this case, you have crest. The upper one is called crest. The valley is called trough. So in case of transverse wave, the wave propagates in the form of series of crest and trough. In case of longitudinal wave, the wave propagates in the form of series of compression and rarefaction. This is the major difference. Repeat what? This. So in longitudinal wave, the wave propagates in the form of series of compressions and rarefactions. Right? At compression, the density and pressure is maximum in the medium because a lot of particles are packed in a small volume. At rarefaction, the density is least or the pressure is least. In case of transverse wave, right? It is a crest and trough. So what is crest? It is the displacement of the water molecule from its rest position, the maximum displacement on one side. Then the maximum displacement on the other side. So the top position is called crest. The bottom position is called trough. And it will just keep on doing that. And during the wave propagation, no water molecule goes along with the wave. It's only the disturbance which is going. Is it clear? Okay, like I told you, I am not going to her. It is passing. Okay. By itself, through adjacent particles. Like I give you this, you give to her. So like that day I gave the example too. So when we pushed each other, so I pushed him, he pushed the next point, and the next point, like that. So I caused the disturbance, but it reached till the last person. Okay. So we are the medium particles. That way. Okay. So is the propagation of wave understood by everybody? Now if you read, it will become clear and you can ask questions. So what is that? This is longitudinal wave. This is transverse wave. Okay, students are online. Okay. Yes, please. Sanmitra Shekhar. Any question, online students? Can't hear. Is the speaker not working?
No, sir.
देखो स्पीकर काम नहीं कर रहा है क्या? Is it on?
No, sir.
Where is the switch? Acha, that one. Is it on now? Diya, say something again. Have you understood?
Yes, sir.
Still not on. Huh? Red. Now it is on. Yes, Dia, once again.
Yes, I understood.
Okay. Now the speaker is working. So, okay. And Dia has understood. What about Sanmitra, Samriddhi?
Understood, sir.
Okay. Samriddhi or Srinidhi? It's Srinidhi.
Yes, sir, understood.
So next, we will see an experiment which will tell you that sound wave cannot travel without a medium, right? Can I erase it? Can I delete it? Erase it? So experimental verification or to show that sound wave needs medium for its propagation. Okay, so what is the experiment? It is the bell jar experiment. Bell jar experiment. Right? So you can see the diagram, figure 12.6 in your book on page 162. Right? So what you have here is you have a glass jar, right? In which there is a pipe fitted to vacuum pump. Okay, and now a bell is hanged here, right? So it has a bell. So it has a hammer here. Okay, so when the supply is provided, when this switch is pressed, what happens? This bell will begin to ring. So initially, when that is the time the sound is heard outside. Okay, when there is air, that time you can see that the hammer is hitting the gong, and you can see the sound of hear the sound of the bell. Right? Now, when the vacuum pump is switched on, the air is sucked out. So what remains here is vacuum. Okay. So while the bell is ringing, right, you are able to hear. Now switch on the vacuum pump. Then slowly you will see that the sound begins to reduce. And a stage will come that this hammer is hitting the gong, but you are not able to hear the sound. Why it has happened? Because now there is completely no medium. It is vacuum. Okay. So this is why it is. So this is a verification that sound requires medium to travel. So how did the sound reach you? When there was air, okay. So when it hit the gong, this started vibrating. Then it disturbed the air particle. Those air particle disturbed and reached the glass, the wall of the jar. This started vibrating. Then it disturbed the air surrounding it. Those air disturbed the neighboring air particle, and then it started disturbing the air. So through particle to particle. No particle from this side came out. It's only the vibrations. Understood? So this experiment confirms the need for medium for sound wave to travel. Okay. Next. Now, characteristics of sound wave. characteristics of see, these are characteristics of wave in general. Okay, not necessarily sound wave. Any wave would have these characteristics. So waves would have what it would have. It would have frequency. Then it would have amplitude. Right? It would also have wavelength. Okay. So speed we'll see. So these are the characteristics of any wave. So we heard that sound wave travels in the medium in the form of compression and rarefactions, right? Then rarefactions like that. Why it happens, that also I explained. So when the source which is vibrating, which is creating sound, right? So when it is vibrating, a low pressure region which we call rarefaction, a high pressure region which we call compression is created. And through such series of rarefaction and compression, the sound will propagates. How it is propagating in this direction. So in terms of pressure, right? How do we represent it? So we'll represent it like this. Wherever you have compression, right? Wherever you have compression, the pressure is, this is pressure or density, right? So wherever you have high pressure, you will show a peak like this. Wherever the pressure is low, it is like this, value. You understand? So this is high pressure, that means compression, right? This is low pressure, that means rarefaction. Again compression, again rarefaction. Like that, it will proceed. So where is the pressure maximum? At this point. Where is it minimum? At this point, right? So what is the wavelength? Wavelength is this distance, right? The distance traveled by wave between two compressions or two rarefactions. Okay, this is this distance. Got it? And the time the wave takes to travel from one compression to other compression is also called as its time period. Right? So wavelength is represented by a symbol called lambda. It is the distance between two consecutive compressions or rarefactions. Got it? So that is what is lambda. So lambda is a distance, right? So from A to B, let's say this is AB, right? This is called one wave cycle or one vibration, right? So what is one vibration? So when the particle vibrates, right? So it starts from the mean position, goes to one extreme, then comes back, and then again comes back to its rest position. So this is one cycle. So when the particle goes from here to here to here, that's when the wave has traveled from here to here. Got it? So I think this I had explained in the last class. Vibration, right? Or one wave cycle. Huh? What is the first? This one. This is called lambda, this symbol. It is the symbol for wavelength. It's a Greek word, lambda. Lambda. Okay, lambda. It is the distance between two consecutive compressions of wave function. So the time taken by the particle of the medium to complete one wave cycle is called its time period. So for the particle to complete one cycle or the wave to travel distance lambda is time period, right? So time taken is called time period and it is denoted by symbol capital T. It is also the time taken by the wave to travel one wavelength. So when the wave travels by distance lambda, the time taken is called time period and it is denoted by t, right? So this is the wavelength. Then here time period. Let us see now what is frequency. It is denoted by f or nu. What do you write? Nu. It is the number of wave cycles completed in 1 second. 1 second में कितना cycles होता है? That is frequency. Right? And what is the relation between frequency and time period? F is equal to 1 by t. Because in t second, one wave. So therefore, in 1 second, 1 by t, which is nothing but frequency. Okay. So what is the unit of frequency? Per second. Or it is also called as hertz. So this is the relation between frequency and time period. Yes. What's called time period? Okay, now what is amplitude? So what is amplitude? So the maximum displacement which the particle undergoes from its main position is the amplitude. And in terms of pressure, it is the maximum pressure, right? Or density. So It is the maximum displacement that the particle of the medium undergoes right from its rest or in position during vibration. So, and in case of wave, so this is in case of particles, right? But in terms of wave, sound wave, it is the maximum pressure or pressure is similar, right? Maximum pressure or density at a point this is called nu, like this is called lambda. Nu, nu, nu. Okay. In terms of sound wave. It is the maximum pressure or density at a point during its propagation. So first write the here and explain what it means. So it is maximum or minimum, right? Maximum or minimum. Both are empty. This is maximum position. So in terms of pressure, maximum pressure. So here also the pressure is least now in this case at real pressure. Got it? So both are at the same place. So do you have any questions? समझ आ रहा है कि नहीं आ रहा? So give me the confidence that you are understanding. कोई question है तो पूछो, because that's the only way. Ah. When I'm speaking, right? So the air particle near me is not entering into your ear. It is just oscillating like this. Then it is making the other particle oscillate. But how is it oscillating? Like, let us say these are the four particles. Okay, these are four particles. When I speak, it goes like this. Okay, when it goes close to this, then it disturbs it. Then all of them become very close. Then they become like this, like this. This is the motion. And there are four particles, things like that. Okay, so this was its rest position here. Okay, now when I start speaking, it goes from the rest position till here, and then comes back again. Because what are the characteristics of the medium needed for sound propagation? The medium needs to be elastic. मीडियम कैसा होना चाहिए? इलास्टिक होना चाहिए. तो इलास्टिक मीडियम की क्या प्रॉपर्टी होती है? जैसे ही बाहर का फोर्स हटाया, it will restore its original position. So when it tries to restore its original position, it doesn't stay there, it overshoots like a pendulum. This was its rest position. Now when it is moved, then it doesn't comes back and rests there only. It goes ahead. So this is due to inertia. So medium also should have inertia, right? And it should have less friction also. You got it? So depending upon the medium, since it is elastic, so what will happen? The air molecule which was resting, now it will start vibrating. So जितना ज़्यादा दूर जाता है, that is the amplitude. See, so lowest pressure is minimum in terms of pressure at rarefaction. It becomes minimum because now when these molecules are pressed together, there are 3 molecules per unit volume. Let's say there are only 4. When the all 4 come together, in the unit volume, how many molecules are there? 4. Now when they spread apart, in the unit volume, how many molecules are there? That's only 1. That's same one. That's minimum. So density or pressure is least. So the maximum pressure and the minimum pressure. Understand? So both are amplitude. Or if it is confusing you, just keep it wherever it is maximum. Let it be like that. Okay, but it is minimum also. In terms of pendulum, it is maximum displacement on both sides. So in terms of particle also, it is maximum displacement. So in terms of displacement, it is maximum. But in terms of pressure, what is it? It is more pressure when all the particles are together, and then least pressure when all of them are spread apart. So pressure के केस में minimum भी आएगा. समझ आया? So you can understand amplitude from 2 concepts: pressure concept as well as displacement of the particle of the medium. समझ आया? थोड़ा टाइम लगेगा, तो 1-2 बार पढ़ो, फिर नोट्स में क्लियर हो. ठीक है? All right. Now, can I erase this side? So we covered. Okay, now speed. So there was one more characteristic. You can write speed of the wave, right? Speed. I gave you 3 characteristics, like 3 or 4. Speed of the wave. Speed of wave. So this is wave velocity. What is the velocity with which the wave is propagating? Right? So let us say the wave is propagating with the velocity v. Right? Then in time t, how much distance it will travel? We know that in time capital T. The distance traveled by the wave is traveled by the wave is how much? In time capital T, time period, what is the distance traveled? We know that in time capital T, the distance traveled by the wave is one wavelength, lambda. Is one wavelength. Isn't it? Time period का definition देखो क्या लिखा है? Therefore, speed is distance upon or displacement upon time. What is speed? Displacement upon time. Therefore, V is equal to F lambda. Hence, F is equal to 1 by. Correct? So this is the formula for speed of sound wave. Right? So you can write speed is equal to distance upon time. So distance is lambda and time is capital T. Right? And what is 1 by T? F. This is all. So in the characteristics of sound wave, they are covered what? Frequency, amplitude, and speed, right? There are some more characteristics like loudness, of sound wave. What is loudness? Whole volume, right? So loudness depends on amplitude, right? So loudness of sound wave depends on the amplitude which is like energy of the wave. Okay, let's say what's the name? Huh? Sarthak. So I am speaking, I am calling your name Sarthak. Okay, then I say Sarthak. Both sounds are very similar. You know who is calling your name. So the frequency is same. But what is different? The amplitude. Which is frequency. Loudness is means the frequency same, but amplitude different. What if, like your mother, when she is near you, she calls you softly. But when she is in a room or when you are in a room, she will really yell. Okay, but you still know that it is your mother only who is calling. Okay, when your father calls you, then you will know that it is your father. So there is a difference between the sound. Two different sounds are different in terms of frequencies. Loudness is same person speaking with more energy or less energy. Got it? So loudness of the sound wave depends on the amplitude of the wave. Okay. But what is loudness? A sound which may be loud for me cannot be loud for a old guy. Same sound will not be able to vibrate his eardrums the way it is able to vibrate the eardrums of a sensitive ear. Right? Like some people like they enjoy loud music. You can enjoy only when it is pleasant to your ears, but to some it will be very noisy. Understand? So loudness is also a subjective thing. It is a response of the ear to the sound. Okay, what is loudness? Loudness is the response of the ear to the sound wave. So it is a subjective quantity, right? So hence loudness is subjective property. Subjective. So what is not subjective? The intensity. The intensity of sound. What is intensity of sound? It is the energy flowing, sound energy. Which energy? Sound energy per unit area, per unit time. Okay. So energy upon time is also power. Work upon time is power. So power flowing per unit area. Right? So this is the objective property. Mathematically, two different sounds will have different intensities. Right? So it's the objective property. Density is objective. What is objective property? The intensity of sound. They are all related. Loudness, intensity. Any questions here? Likewise, there is something, another characteristic of sound called pitch. So it depends on frequency of sound. Okay, now draw two waves. Okay, so for loudness only. So you have which is a loud sound? One or two? Okay. So both are completing the cycle in the same time. This is time. Right? The cycle is completed in the same time, but here the amplitude is 4. So this is a louder sound. Right? So loud. Now here we have, from the waveform you can identify. which has higher pitch? First one is a higher pitch. Which has more waves in the same time? So in this much time, 2 waves are completed. So this has higher frequency, high pitch, right? So sound are different because of its frequency. So male voice has low frequency. Female voice has high frequency, right? So males have low frequency. Or flat voice. Right? Because the vocal cord of male vibrates less. And girls' vocal cord, like that, very piercing, very high pitch. Hey. Got it? It's like that. Either off. It's like that. Cross, might be a cross, transgender. So these things, so sensibility. And some demons are also having a heavy voice, right? So these are like hormonal things, right? Ultimately, we are derived from the same source, right? So it's quite possible. That's what. Don't we have meek husbands? Yes, like that. Then you're really as a so it's all possible. So males have low frequency of flat voice. Females have low frequency or low pitch. Females have high pitch or frequency. So what is their voice called? Shrill. Hence, shrill. Shrill. Why am I a female? That's what she's done. Is it bothering you now? No. Shrill is good. I love listening to Lata Mangeshkar songs. Very good. That's good. What happened? Voice very quiet. I've erased it. It's okay. So you need to understand these technicalities, difference between sound. So males have high bass, right? High bass, right? Females have high treble. Treble or terrible. Treble. Treble is treble, not treble. Treble. Bass like the drums, they have high bass, right? And treble is like sitar, treble, the shrill sound, which is like harsh in ears. Bass or bass, it's called bass, right? Okay, next is quality. So what is quality? type of. So, like there could be two different musical instruments and they are played. Now they have same amplitude and same frequency. Now how do we distinguish? Just by hearing you can understand that this is coming from flute, the other one is coming from violin. Okay, so they are played at the same amplitude and same frequency, still they are different. Why? Because their source is different. That is quality. So when two sounds have same pitch and loudness, right? But still sound different. Means they are produced they have different quality. Quality or waveforms. But two sounds of same pitch and order, but not is not sound is different. No sounds. It sounds different. In hearing, right? Sounds different. Means they have different quality of waveforms. As they might, as they are produced by different musical instruments. So I gave you the wave for loudness, frequency, now for quality. The two different waves could be something like this. So one is like this, the other could be like this. Okay, so same amplitude, right? Same frequency, but different waveforms. All right, so let's take a next.